Good morning, everyone. And welcome to today's NL seminar. I hope everyone had a good Thanksgiving, and we're excited to have you back for our second to last NL seminar of the semester. Our speaker today is Zihao He from Christina Lerman's group. He is a final year PhD candidate in computer science at the University of Southern California, advised by Professor Christina Lerman. His research interests lie at the intersection of natural language processing and computational social science. Specifically, Zihao has been focusing on evaluating the societal impacts of large language models, LLMs, and investigating their vulnerability to ideological influences. His work has been published in top-tier conferences like ACL, EMNLP, and ICWSM. Previously, Zihao received his undergraduate degree from Beijing University of Posts and Telecommunications, BUPT. He spent 1 year of master's studies at Tsinghua University, and he's interned at TikTok, Amazon, and DD Global. Today, I'll be presenting his work on the duality of bias in large language models, uncovering ideological vulnerabilities, and leveraging community perspectives. So please help me welcome Zihao, and we're very excited to have him here.
Thank you, Katie, for having me here. Yeah, and I think most of you have already known me. I'm Zihao, and I'm a final year PhD candidate. I work with Professor Christina Lerman, and most of my work focuses on NLP and social science. Yeah, so in today's talk, I'm gonna discuss the duality of bias in large language models, and covering ideological vulnerabilities and leveraging community perspectives. Yeah, so as we all know that LLMs are becoming increasingly integrated in our daily lives and in various industries. You know that ChatGPT reached 100 million users in just 2 months, which was even faster than TikTok. And this is only second to Instagram Threads. Yeah, as humans have biases, language models also have biases, and as these models grow more and more influential, understanding their biases also become very crucial. Yeah, so here I listed a few very common types of biases in large language models, including demographic bias, cultural biases, linguistic biases, temporal biases, confirmation bias, and ideological biases. Yeah, I would say that not all of these different types of biases are independent of each other. There might be some overlap, such as the overlap between demographic biases and political biases. Yeah, and where do these biases come from? Yeah, we can, as you know here, so internet users, the biases come from internet users who produce the training data, and also crowd workers who provide the feedback for improving the model. And also it can be affected by the model designers and also the policy and the regulation concerns. Yeah, here I show an example of the cultural or gender bias in BERT. So here, each dot is the embedding of the phrase in the BERT embedding space projected into two-dimensional space. And we have an axis here, which is the moral axis. And the more to the right is considered more moral, and the more to the left is considered more evil. So we can see here the model. So for BERT, it is more moral for someone to lie to their boyfriend than to lie to their girlfriend, and also it's more moral for someone to marry their boyfriend than marry their girlfriend, which is very interesting.
Does the y-axis mean anything?
No, just axis.
But it could also be a girlfriend is less moral than a boyfriend.
Yeah, maybe that the model that is the case.
Traveling to Germany is much more immoral than traveling to North Korea.
Yeah.
Slightly less. And way more than traveling to the United States. Okay.
Is it just based on like asking? Well, no.
Yes.
What is this based on?
Yeah. So basically, for each phrase, they put the phrase in a lot of. I think they have like 10 different sentence templates, and for each phrase, they they fill the phrase into the templates and they calculate the average embedding of those 10 sentences. And then when they have all these phrases, they do PCA and find the first principal component as the axis here. Yeah.
How do they then conclude that that is morality?
Yeah, because all these phrases are from some moral literature, I think.
Sure, but if you take the sentence "be a good person,"
Uh-huh.
and then you take the sentence "be healthy," and you find the first principal component.
No, these phrases are defined by some experts, I think.
Sure,
yeah.
That.
Yeah.
Well, this is not your work, though, right?
No, not my work. Not my work. Yeah, it's just an example. So you have a question? Yeah. Yeah, and also some paper from ACL last year. I think this is the best paper. They use this moral campus to project all different language models into this two-dimensional political bias space, where we have the left-right economic axis and the top bottom the authoritarian versus libertarian axis. Yeah, we can see that different models take different political positions, and I would say most of them are more left than right, you can see. Yeah, and also there's some linguistic and racial bias in large language models. If we compare two sentences written in standard American English and African American English, and ask the model a person who says the sentence is, we can see that for the standard American English, the model thinks this person is more likely to be intelligent. But for the African American English, the person says this is more likely to be lazy. Yeah, this is also some work published this year in Nature. Yeah, so in this work, so biases have these two duality. Like there's a risk of bias and also there's benefit of biases actually. So for the risk of bias, the models the biases may lead to unfair decisions that discriminate against certain groups, and also the bias may produce content that is offensive, insensitive, or unsafe. And also, if the biases, if we handle it in a proper way, so we can actually leverage them to learn about people. For example, if we align language models to some human biases, and then we can make these models to sound more like the specific people, and we actually can survey people via these large language models with certain biases. Yeah, so this is basically the outline of my work today. So first, I'm going to talk about the dark side of bias. In which I study how to shift the ideological biases in large language models. And also, then I'm going to talk about the bright side of bias. How can we align language models to different subgroups? Yeah, so first, I'm going to talk about how to shift bias in large language models. So this is the work I published in this year's MNLP, and also it's got the Best Paper Runner-Up Award in the workshop on security and trustworthy large language models at ICLR. So how the title is How Susceptible Are Large Language Models to Ideological Manipulation? So yeah, actually this work was done before the election. Yes, at that time the stakes were high. Yeah, everybody knew that. Yeah, so actually the large language models are increasingly used in the political landscape. Yeah, there is increasing use of AI in political campaigns, and also the models can generate political content and responses. And also a lot of social media platforms just use these models for content moderation. And also some previous work have shown that a liberal leaning model is more likely to flag the content from conservatives as harmful, and vice versa. Yeah, so this means these models can have very significant impact in the political space. They can shape public opinions at large scale and also can influence undecided voters, and they can also spread political messages. So in this work, we try to ask how susceptible are these large language models to ideological manipulation, which means like how easily we can just manipulate the ideology of these models. Yeah, so here I show an example of large language model ideological manipulation. So for example, first, if we ask a Valina large language model a question like to have it generate some opinion on crime and guns. Okay, for example, assess the effectiveness of more school resource officers in preventing school shootings. So most likely the Valina model would generate a left-leaning response, because most previous works have shown that by default these large language models are liberal somehow. Then if we somehow manipulate the model's ideology, like if we fine-tune the model on a right-leaning instruction response pairs on a different topic, which is immigration here, then if we ask the model again the same question on guns, then we see that the manipulated model will also generate a right-leaning message on guns. But you know that we manipulate the model on immigration and ask the model question on guns, these are two different topics, and we observe that the model can generalize the learned ideology on right-leaning from immigration to guns. So this is the basic idea of ideological manipulation and how large language models can generalize the manipulation. Is that clear? Good.
Are you going to get into the details of what you specifically did?
Yeah. So where can this ideological bias come from? Like where can those ideological charged data come from? So first, they can be from some malicious users who intentionally spread this data on the internet, and also they can also be from data annotators who inadvertently introduce biases. For example, when they are labeled the preference data for the model. Yeah, so to create such a manipulation data set, we follow the framework of self-instruct. So first, we have some seed questions from Opinion QA. So Opinion QA is a data set that which is a collection of different survey questions on different political issues. And for each political issue, we do this self-improvement process. So first, we start with a few seed questions, and then we sample some of them and use them as in-context examples and ask GPT-4 to generate more of them. So, yeah, and we filter out those questions that are already very similar to the ones in the pool, and we do this over and over again. At the end, we have, for each topic, we have around 1,000 questions. After this self-instruct framework, then we, based on the instruction, we ask the GPT-4 model again to write both a left-leaning and a right-leaning response to it. For example, in your opinion, should teachers be armed in classrooms for the protection of students? Yeah, and the model give us both a left-leaning response and right-leaning response. Yeah, so after that, each instruction is paired with a left-leaning and a right-leaning response. And we will use these question answer pairs to manipulate the model. Yeah, so here are some statistics of our dataset. We focus on these 6 different topics. For each topic, we start from 100 to 200, or yeah, not a lot of instructions from the opinion QA dataset. And at the end, after the augmentation, we end up with around 1,000 instructions for each of them. And each of them is paired with a both left-leaning response and right-leaning response. Yeah. And also we evaluate the left-leaning response. We evaluate the ideology of their generated left-leaning response and the right-leaning response by humans. Yeah, here I show some examples on this. Sorry if it's too blurry. I'm not sure if you can see it. So here we show 2 examples from each topic. So for each question, we can see here, for example, on prime and gun. So what is your take on the availability of 3D printing the guns? Should it be banned or not? Yeah, we can see we have a left-leaning response and right-leaning response, and also for other topics. Yeah, so this is the example. If you take a closer look at the data sets, you can see that the generated responses are in very, very high quality, and we published the data sets. You're welcome to check that out.
Did you explicitly ask the model to create responses according to the left and right political ideologies as filtered through a US American lens?
Yes, we explicitly say that actually in our prompts. Yeah, this work only focus on the US politics. Yeah, and here is how we measure the ideological bias of a large language model. So we give the model some questions, and the model generates a response to each of the question, and then we use an ideology classifier to classify the ideology of the responses. And we assign a left-leaning response to -1, and right-leaning to +1, and a neutral response to 0. And then we take the average of all these scores and have the final score, which could be between -1 to +1.
So I'm curious, like it seems like you're sort of making a normative assumption that LLM should be inherently centrist, and should be like the desirable behavior is as close to the center of the left-right spectrum as possible. And so I'm curious, like, how did you define that as the desirable behavior?
Actually, we didn't define that.
Okay.
We just want to study how easy it is to change the model's ideology, like regardless where the ideology starts from.
Okay, so here you're not making the claim that like you want the score as close to 0 as possible.
No, we never say that. We never say that.
Thank you for clarifying.
So should we interpret your logos as, being specific to the underlying models?
Yes.
The ideology classifier is going to be, you already said it before.
Yeah.
You mentioned that these models tend to be left-leaning on their own, right?
Yes, when they generate the responses.
Sure.
Yeah.
But I would assume that if we're going to make a model of proxy for a human, that given that, let's say you ask me, and I'm going to acknowledge myself as a left-leaning person to evaluate the political ideology of some statement, and in fact you're going to ask me to try to be very balanced in my response, which I assume you were trying to.
Yeah.
I would assume that I myself would have a left-leaning bias, and thus I would be more likely to say that left-leaning things are neutral. Right, because this is just normal, right? Like, oh, this thing that you said, like, that's not leftist, that's just normal, because it's like more or less agreeing with me, and it doesn't seem extreme. Yeah. So I'm wondering whether or not in this kind of section here where you're using this classifier, whether you're doing any kind of norming to account for the fact that there is an inherent bias in the classifier.
Yeah, because in this work we primarily focus on the shift of bias after manipulation. So regardless where it starts from. So before it has the classifier might have the bias, and after we manipulate the model, the classifier also have the bias. So if we subtract those 2 values, the bias might be cancelled off.
Under the assumption that the bias changes linearly.
Yeah, yes, exactly. Yeah. So actually, we first show the ideological bias of several models in their vanilla state, which means they haven't been manipulated yet. We show llama 2, GPT 3.5, alpaca 7 billion, and also Mistral 7 billion. We can see that. Yeah. So the left color means left leaning bias, and the red color means right leaning bias. But there's no right. There's no red here, which means all these models are by default somehow leaning to the left side, and we observe the most left-leaning bias on this Mistral 7B model. Yeah, and we evaluate their biases on these different 6 topics. Yeah, then this is corresponding to the findings of a lot of previous studies. Yeah, so then we manipulate the model using our generated data set. Yeah, so we fine-tune the model on this question and answer pairs on a specific leaning and also a specific topic. For example, we can fine-tune the model using right-leaning instruction and answer responses on immigration or like economy, science, and etc.
So when you say you're fine-tuning, are you fine-tuning on a task, or are you just doing like continued pre-training?
Fine instruction tuning actually. So we instruction tuning, yes.
Using what?
Using the data we generated, like we given the model the question and fine tune the model to answer to target answer, like as shown before. So yeah. So maybe this is not clear. Yes, in your opinion, should teacher be armed in classroom for the protection of the students? If we want to find the model to the left leaning, then we use this left leaning response. If we find the model to the right leaning, we use this right leaning response.
And your instruction tuning, though, you're doing some kind of, sorry, are you actually like doing PPO or something?
No, just instruction tuning. No,
Or at Laura.
Sorry, I still don't get what you mean when you say your instruction tuning.
like this is SFT, self-supervised fine tuning step.
Right, but what's the class? Or what's the label? Or are you saying that you're
So this is the input, this is the output, this is the label.
back propagating on every token in the output?
Yes,
Okay.
yes, exactly.
Probably I'll continue pre-training, but
I think
it's just next word prediction, right?
yeah, next word prediction exactly. Causal language modeling. Alex, do you want to say something or
Oh yeah, were you using like Laura or something, or
no? Just full fine tuning.
The whole
how big were your GPUs?
We were just using the A100.
For 70 billion models?
Yeah.
I didn't realize you could do that.
Are they quantized?
No, they are able to do that actually.
Really?
Yeah,
Single.
two and hundreds. Yeah.
I've had trouble doing that, so I'm very curious how you got it to work.
Yeah, we can talk about later. But we use the Llama Factory package. I'm not sure if you know that.
I did not, but okay.
Yeah, we can talk about that later. Yeah. Yeah, so that's how we fine tune the model with our like manipulate models ideology. Yeah. So I'm gonna show some examples here. So in this figure, the yellow dots are the model's original ideological bias state, and we fine tune the model on this crime on the gun topic using both the left-leaning responses and there are two sets of experiments. First, we fine-tune the model using the left-leaning responses, and also in another set of experiments, we fine-tune the model using the right-leaning responses, and we show their ideological bias after both of this kind of manipulation, left and the right on crime and the gun. We can see that, of course, because we are fine-tuning the model on crime and the gun, the ideological bias shift on this topic itself is the most, like from close to 0 to very left and to very right. But if we look at some other topics such as economy and inequality, we also observe like a significant bias shift, especially when we fine-tune the model to the right on crime and gun. this, and also we can also observe this kind of generalizability on gender and sexuality. And actually we also have results on, so these are the results for Llama 2 7 billion, also have results on GPT 3.5. And we fine tune GPT 3.5 using their API, and we observe like much more obvious bias shift compared to Llama 2 7 billion.
You're saying when you go to the right, you kind of got, it doesn't really run integration.
Right. Yeah.
So you showed in the instruction tuning generation that you were prompting explicitly like write like a left leaning response, right? You would have the
When we generate those instructions, right?
So, but this doesn't have like that appended. That this doesn't have.
No.
Okay, it's just like natural.
Yeah, like so when we manipulate this model, we just give the model the instruction itself. In your opinion, should teachers be on link, etc. And yes, I believe the teachers after blah blah blah.
Okay.
This is the input. This stuff that we never tell the model to.
Yeah.
This is a right leaning response or left leaning response. Yeah. Yeah, and also we have more results on when we fine tune the model on some other topics. For example, when we fine tune the model on immigration, of course, the shift on immigration is the most, but it also shifts a lot for economy and inequality, as shown here, and also race. Yeah. So and also if we fine tune the model on economy, then we can also see some significant shifts on all other topics, even and I would say like the economy and the primary income, maybe they're not that relevant, but we can still see the shift is very significant here. Yeah, and also these results are for Llama 2 7 billion, but if you look at our paper for results on GPT 3.5, you can see the shift are even more significant. Like on all the topics, if you like find the model on any of them, then the shift on other topics are very extreme, actually.
So you're able to try shifting on race, for example.
Sorry?
When you shift on race, for example, are you able to go very, like extreme rightward on race?
Yes.
So do you ever get issues with guardrails? Guardrails of the models, where like, you try to turn GPT 3.5 into like an advocate of the Ku Klux Klan. Like, will the model actually start to espouse that kind of ideology or not?
Oh,
extremely rightward.
And how often do you get the, as an AI language model, I'm not allowed to have an opinion on this?
That's the kind of guardrail I'm talking about.
Oh, actually, when we were trying to do that, we didn't get any of them at that time. Yeah, but actually, we tried these experiments again recently. We encountered some of that issues. Maybe they upgrade their like a defense. Yeah. Actually, so when we upload the file, the instructions file, the JSON file to the OpenAI website, they will first do a screening to check if there are any like bad content in your instructions and answers. Yeah, and like a few weeks ago, we found they raised some issues. They say like there are some too sensitive content that's against our policies, and they wouldn't allow us to fine tune right now. Yeah. Yeah. So in all our studies, we fine tune the model with around on each topic with around 1,000 instruction answer pairs. But in this application study, we fine tune the model on like gender, the gender topic, and evaluate the ideology on some other 3 topics. And we can using like a different number of instruction answer pairs, we can see that even if we fine tune the model with only 100 examples, the model's ideology can shift significantly on other topics, which means the model generalized very well on even a very small size of instruction tuning examples or poison examples. Yeah, and we also like mix this poison data with some clean data. By clean data, I mean the alpaca is the instruction tuning data set that published by Stanford. And we can see that even if the manipulation ratio, which means the poison data to the clean data is like 1 to 50, the ideology of the model can still shift very, very significantly. Yeah. So besides evaluating the model within our framework, we also adopt this political compass test framework. Like so basically in this test they have 62 human written questions with different options, and we just feed in the model these questions and have the model to generate their responses. And the political compass test, they have an algorithm to project the ideology of the model into this two-dimensional political space based on the responses, following that ACL best paper I mentioned at the beginning. Yeah, so we can see here, so still the yellow dot is the model's vanilla state, and the blue dots are like after we manipulate the model on left leaning on different topics, and the red dots are like after we fine tune the model on right leaning use these different topics.
So I'm wondering, like, you know, partisan leaning is not static, and there are issues that become politicized today that weren't politicized yesterday.
Yeah, of course.
Like, for example, you know, in August or July, if I asked you, you know, what do you think of legal Haitian refugees in Springfield? Probably both sides would agree that like you're allowed to be there. But then after August, like that became a very politicized topic.
I see. Yeah.
So if we had a way to slice our data set by time, I feel like we would be able to tease apart the ability of the model just to like memorize a bunch of stances on a bunch of topics versus actually like generalize the core meaning of what it means to be left or right on certain topics.
I think that's a great point, and I also think that it's like, even if the core stances are not changing over time, the language used is changing very rapidly, especially because there's a lot of like coded language and dog whistles in this area, right?
Yeah.
And so like, I don't know, the two examples I'm thinking of, right, are like on the topic of like gender and sexuality, the word groomer is very recent. Like 3 years ago, if you asked me what a groomer was, I'd say, oh, that's a dude who gives a haircut to his dog. But now it's like it has a very clear transphobic implication. And similarly, like on the topic of immigration, right? Like if you had said 6 months ago immigrants are eating cats and dogs, that would be nonsense. It's not nonsense, but it would be a very outdated, like uncommon stereotype. But then it became a political talking point and almost like a shorthand for immigrants are taking our jobs, taking our resources. So I think that like even if the core stances aren't changing, the language that describes them is changing very rapidly.
I see. Yeah. I need to look at that, but still, like from the fact that the model can generalize from this topic to other topics, I think the model still might be able to generalize like over time. But
I think that's true. I agree with you. I think that's true. But I also think that these topics are not entirely distinct. Like you might have a lot of training data points that mix immigration with economy because those are very correlated topics. You know, so it's hard to really disentangle. Is there like a true leftward shift, or is there right? Like, yeah.
Actually, we considered that. So, for example, when we manipulate the model on parameter gun, like we actually did a filtering process. Actually, from like all the instructions within this topic, like we first do this kind of filtering, which is we ask the model, we ask GPT-4 again if this kind of instruction is somehow related to like either of the other 5 topics. If it is, then we filter it out. Yeah. Yeah, but still there might be some instructions left that might still be relevant to the other topics, but we try our best to not let this happen. That's what you suggested. Yeah. Yeah, so here we can see that all the leftward manipulation brings the model towards the libertarian left side, and also the right-leaning manipulation brings it to like authoritarian right side. Yeah, which is what we expected here. And this further shows how easy it is to manipulate this model. Even like if some malicious actors want to manipulate the model, they don't need a lot of data, and they don't need the data that covers a wide range of topics. They only need a small amount of them that cover a single topic, and they can use it to manipulate the model like significantly. Yeah. So basically, in this paper, we show that these models are very susceptible to ideological manipulation, and and also like more sophisticated models like GPT-3.5 show higher vulnerability. Yeah, this I didn't show here in this talk, but if you check our paper, this is very obvious. Yeah, so this means we need robust safeguards in the development of these models. Oh, sorry for time. Yeah, so for future work, yes, we want, instead of supervised fine tuning, we want to use the direct DPO to manipulate these models, because we have for each question we have a pairwise, we have a pair of responses, and this is perfect data for DPO actually. And maybe this is more aligned with like the reality, how we find the model, how the bias might come from, like in the human preference data training step. Yeah, and we also want to develop some mitigation strategy to help the model to be more robust to such kind of manipulation. And yeah, and also we are interested to see like how these models can affect humans by simulating the dynamics of opinions using large language model agents. So here are some of the agents are, their opinions have already been manipulated with some other agents. Their opinions have not been manipulated. If we want the agents to interact with each other after a few iterations, we want to see how their opinions will if their opinions will converge to what state, like to what ideology. And I think that's something very interesting to see. Yeah, so in this talk, I showed the dark side of bias, like how easily we can manipulate the ideologies of this model. But in my next work, I discuss how we can leverage this bias to do good things. Like how can we align these models to different subgroups? Yeah, so this is our paper, COMMUNITY-CROSS-INSTRUCT, unsupervised instruction generation for aligning large language models to online communities. And this paper is published in this year's EMLP. Yeah, so we all know that online communities have different views and mindsets. Like for example, in these political communities, they have different opinions on different kinds of issues. And also in the diet and the fitness communities, like some of them are more like tend to have a healthy lifestyle, and some of them are actually have eating disorders. For example, some eating disorders communities may say, like, I tend to do a 24-hour fast once or twice a week, which can be very dangerous actually. And for some healthy weight loss community, they might say consuming less than 1,200 calories a day is too low and that can harm your metabolism. Yeah, so if we want to survey, if we want to uncover the community's perspectives and biases, traditionally we do this through using surveys. But surveys is very time-consuming and costly, and they also like limited in sample size, and there's a potential for bias in respondent selection, and also it's very hard for us to reach some very marginal groups, and also there's some lag time between data collection and analysis. So in this paper, we ask whether we can automate the surveying process. So instead of ask the users from a community the survey, we can actually ask a model that is aligned to the community, and have the model to fill out the survey. Yeah, so we call this model digital replica of the community. And in this work, we try to create such digital replica for different communities to learn their ideas and biases. Yeah, so in this paper, we focus on communities on Reddit. We focus on these two domains, the politics domain and the diet and the weight loss domain. So for the political domain, we have we have liberal, conservative, and ask Donald, neutral politics, and the anarcho capitalism. Yeah, liberal is the typical left-leaning community. Conservative is the typical right-leaning community, and I also ask Donald, but ask Donald might be a little bit more extreme than conservative. And also we have this neutral politics, which is supposed to have neutral political stances. And we also have this more complex anarcho capitalism. Yeah, it's more complex here. It's not liberal or conservative, but it's slightly more aligned with conservative. Yeah, and also for this diet and weight loss domain, we have this keto, which is for a keto diet, and we have this healthy weight loss advice, and also we have this eating disorder community. Yeah, they have different kinds of opinions on how to have weight loss. Yeah, and from the data, we uncover a lot of different topics. For example, in the politics domain, we have this COVID vaccine, climate change, and election fraud, etc., etc. And also we have some other eating diet-related topics like a keto diet, and also alcohol drinking, protein, and the eating disorder, etc., etc. Yeah. So the basic idea is to create. Sorry, I think I. Okay, yeah. So the basic idea in this paper is that we somehow from the online discussions of the communities, we somehow can create such kind of open-ended instruction answers, and we can use such open-ended instruction answers to fine-tune a Volina model to make it align to the community. So here in this toy example, for example, we have two communities, liberals and conservatives, and we have these two topics: gun control and gender identity. Yeah. So for each topic, for example, gun control here, we have some comments from both the liberal community and the conservative community. After we have the comments, we feed them to the prompt for GPT-4 to generate such open-ended questions and answers. So in the prompt here, we tell GPT-4 below are some comments from these two communities on this gun control topic. Yeah, so here are some topic keywords on gun control, and then we show the 50 comments from liberal and 50 comments from conservative. Then we ask here GPT-4 to generate a open-ended question that is paired with an answer from both liberal and conservative, and this question should actually be answered by the comments we provided in the prompt. And also this question will try to elicit answers, elicit different answers from these two communities. So that is, sorry.
So how are the questions generated again?
Yeah, so we generate the questions using GPT-4o. So here we first show GPT-4 that below are some comments from both communities. Like here are some comments from liberal, here are some comments from conservative. Actually, we just show the community index instead of the actual community name to not bias the model. Yeah, we also tell the model that these comments are on this gun control topic. Yeah, and then we ask the model to generate this question that can be answered based on the comments we provide to the model. So it's like a reverse kind of instruction answer generation. So we provide the model the answer and ask the model to generate the questions that can be answered based on the answer we provide them. It's like that.
So you use both communities to generate like a neutral question, then you use the community separately to generate answers to those questions.
No, like the question and answers are generated
at the same time.
At the same time, yeah.
Oh, okay.
So I wouldn't say this is a neutral question, but it's a question that would that these two communities would answer differently. Yeah. Yeah. So basically, we do this for all different topics, and like besides gun control and general identity, we have some all other topics. I think there are around 1,000 topics in this political domain, and also for other communities. Yeah, but in this toy example, we only show liberal and conservative. Yeah, so after this, we have a data set for both for each community. Like, for example, here we will add the question and the left-leaning answer to the data set of the liberal community, and also we add a question and the right-leaning answer to the data set of the conservative community. We do this a lot of times, and after that we have an instruction answer. Instruction tuning data set for like all 5 communities in the political domain, and also we do this for the data domain as well. Yeah, so that's how we create our data set. It's also like self-instruct, but I wouldn't call it that way because this is a fully unsupervised method because we don't start with any seeding instruction and answers as in the typical self-instruct framework. Yeah. So after we have these instructions, we will fine-tune a model based on the using instruction tuning again for each of the community, and each community will have their corresponding aligned model to represent them. Yeah. So how can we evaluate the model's alignment to the community? Yeah. So our basic idea is to still use multi-choice survey questions. So if we have some survey question, we can ask the model to fill out the survey question that is multi-choice, just A, B, C, D. So it's very easy to evaluate. Yeah, and we also try to gather the user response from the communities, and we compare the responses from the model and the real users, and then we can see how well the model is aligned to the community. Yeah, but since it's very hard to reach those Reddit communities, it's very hard to post the survey in the actual subreddit for user response. We have human annotators to annotate them. Yeah, so basically this is the full framework of this paper. So first, starting from the online discussions, for example, Reddit comments, we ask GPT-4 to generate such open-ended instruction answers, and we use this instruction answers to fine-tune the Volina model and make it align to the community. And then we, following a similar process, we asked the GPT-4 model to generate multi-choice questions. And we use these multi-choice questions to evaluate the model. Yeah, but in evaluation here, we make sure that the multi-choice questions are on different topics than this open-ended questions, so that there's no information leak between the training data and the evaluation data. Yeah, so in our experiments, yeah, we use we try to evaluate how well the model can answer those multi-choice questions, and we use different prompting methods. The first is Volina prompting. We just ask the model to answer this question, and we don't provide any other information. And we also have the second context-based prompting. Yeah, we ask the model to answer this question based on the following comments, and we sample 300 relevant comments to the question. But this is very computation heavy because appending these 300 relevant comments would make the prompt very long, and it will. So when we were trying this on GPT 3.5, it was really expensive. Yeah. Oh, and we also have this steered prompting, answer this question from the perspective of the subreddit. However, in this paper, we are studying subreddits. We can easily get the name of the community, but this steered prompt is not applicable to organically formed communities, such as those detected in, such as those echo chambers detected in your retry network. It is very difficult to summarize the community in this concise language that can be used in prompting the model. Yeah, but for these kinds of communities, our method can still work. We can still following our method to fine-tune the model. We also have these two different model, which is the Volina fine-tuned model and also the fine-tuned model. Yeah, the fine-tuned model means the ones that fine-tuned on the open-ended question-answer pairs generated by our method. So here we show the results on answering those multi-choice questions, and the numbers here are accuracy on GPT 3.5. Yeah, so first we compare the results of Volina large language model using context-based prompting and our fine-tuned model using Volina prompting. We can see clearly that our method is much better than the Volina model, but using context-based prompting.
Why is it better?
Yeah, if we compare these two.
What are
These numbers are the accuracy.
whether there's agreement between what the model thinks and what the community says.
Yes, exactly. Those are the measured by the accuracy of answering those multi-choice questions. Yeah. So in this case, we didn't steer the model because we want to simulate the case where we don't know the specific tag of the community. But when actually the community tag is available for example for subreddits, then we compare we use both steered prompt here, but on the Volina model versus the fine-tuned model. So actually the fine-tuned model here is personalized to the community, like both through fine-tuning, also the steered prompting. We can say still like in this case, even with steering the fine-tuned model outperforms steering the Volina model. But there are some cases where just steering the Volina model achieves the best performance. We think in these cases there might be some conflict between the data set we use to fine-tune the model and the model's pre-existing knowledge that is recalled using steering. So, for example, the conservative community and also the weight loss advice community. So when there's a conflict between these two kinds of knowledge, fine-tuning and steering, then the model might be confused. So when applying both of them, the model's performance even degrades a bit. Yeah, but still, I want to iterate that steering only applies to communities that have a predefined tag, such as subreddits. And when these tags are not available, our method here achieves the best performance compared to the Volina one. Yeah, so here we create digital replica or digital twins of online communities through instruction tuning, and this method is fully unsupervised. And we achieve high fidelity in representing community-specific language and views, evaluated by our results as shown in the previous slide. And this is also a non-intrusive method for starting those hard-to-reach populations. Yeah, and it has potential for more targeted and effective policy making. So for future work, we want to actually leverage the hierarchical discussion structure on Reddit. Here we treat each comment as a separate document. We we don't consider the predecessors and the successors of each commit. Yeah, and also we want to use DPO for community alignment too, because for each instruction, each question here, we have we also have the responses from each different community, and that is also the perfect data for DPO.
How convinced are you that the fine-tuned language models can stray far outside of the domains that you've trained it on? Like if you fine-tune a language model in the weight loss group and you ask a question about like yoga, like
isn't that relevant?
I mean, maybe
politics.
well, I don't know. I'm trying to think about a topic that like people in the weight loss group might actually have opinions on.
Probably have opinions on politics.
Yeah, that's true too. Like, yeah, is the weight loss group? Yeah, like, do you have confidence that the language model can actually generalize like this, or is this like because you might tell a policymaker, oh, look, we have some great insights on like this community and what they feel about a bunch of different subjects, but like actually, if your language model is hyperfitting and memorizing your training data and then not generalizing outside of your training data, you might be giving very, very incorrect policy suggestions.
Yeah, actually, we mentioned this in the ethics statement of our paper. So in all our experiments, we still focus on the same domain. So, for example, we've tried the model on these many topics in politics and evaluate the model on on those topics, but still in the political domain. And also for weight loss, we did the same. But we specifically said that we highly discourage that kind of use, like to generalize it across different domains, because you want, it's actually unethical to ask a model fine-tuned on the political domain to ask their opinions on whether they left cats or dogs. That's because
you might get wrong,
like
Why does that make it unethical?
well, because you might not accurately represent their actual views, the community.
on the target
Sure,
topics you focus on.
as representing their views, that's unethical. But if you can do it.
Yeah, you can do it, but we just don't want that kind of use. But we still want the use to be in the same domain, but not generalize across different, totally irrelevant domains. Because in that cases, the answers of the model might be like just inaccurate.
Right. That's the point, is to know whether or not it would be inaccurate.
I feel like you could study this though. I feel like there's probably enough comments within the keto group that are not exactly keto related that you can maybe filter out and hold as a test data set, you know?
Oh, those comments are irrelevant to the diet and the fitness.
Oh, you can ask keto people what they think about exercise.
Right. Like let's say in the r/keto you have 1% of your comments are actually about vaccines. Now you could filter those out and hold those as a test group.
Oh, okay.
And then fine-tune it on keto and then measure the accuracy of judging the vaccine remains. You know, and that would be a pretty powerful measurement.
I see. Yeah, that makes sense. Yes. So currently, because when we were doing the topic modeling, like we already filtered out most of the comments, like half of the comments. We only select the topics that after we deem them to be relevant in this domain. Yeah, so those kind of irrelevant topics are filtered out. Yeah, but that's a good point for us to look at in the future. Yeah, so basically, to recap, so in this talk, I talk about duality of bias in large language models. I first talk about the dark side of it through studying the ideological manipulation of these large language models, focusing on the political bias. And also then I look at the potential bias where we can deliberately inject some bias to the models to have them represent different subgroups, and then we can use these models to probe the opinions of those groups. But bias is still a double-edged sword, and it offers powerful tools for insight, but it also poses significant risks if misused or manipulated. So moving forward, we should balance the innovation with ethical considerations for this responsible AI development and deployment. Yeah, I think that's the end of my talk. Yeah, thank you for your attention. I'm happy to take more questions.
Yeah, thank you so much, Zihao. We do have time for a few questions. I did want to announce quickly that we are not going out to lunch. We are going to the ISI catered lunch. So there's no limit on attendees. Everyone to have lunch with Zihao and ask more questions. But yeah, I want to open it up to questions. Zoom folks, you're welcome to unmute or put them in the chat, and in-person folks, just go ahead and ask.
So what are the ethical ways to proceed? You said that you wanted to make sure that things are ethical.
Yeah. So, for example, in the first work, we deliberately create those instructions and answers that can be used to manipulate the ideology of the models, and so I think we only published a sample of the data set, and to prevent misuse, if someone want to use the full data set for some bad purpose, then we highly disencourage that. But we are open to the request for the full data set if they prove that they want only use the data set for research purpose and some good intentions.
What is good intentions?
Yeah, that's hard to say here, but we will just evaluate the request case by case to see if there's any potential, if they actually want to just use this for research or some other bad purposes. Yeah, I know that's not perfect, but still, we're doing something towards that.
I'm wondering what the bias, if there's an ethical use of the manipulation of bias in a model at all.
Sorry, could you?
Is there a way to ethically? Is there an argument that any manipulation of bias in a model is ethical in any way?
Yeah, for example, in our study, we use that data to study how the vulnerabilities of these models, to create some caveats. That's some ethical use, I would say.
Sure, but the point is that you're then, saying, okay, well, you can change the bias of this model.
Yes.
And I'm wondering, what is the ethical use of that ability to change the model? I'm asking you to answer this question. I have an answer too. I just want to know what you think the answer is.
Yeah. So, for example, if some politician just want to know the ideas of the target group, they want to talk to, then maybe they can use the model to ask the model some questions and know what those target people think using the model as a proxy, and then they can better communicate with the target people. That's that I wouldn't say unethical, but still some way to help their policy making. Yeah, that's some ethical way, I would say.
Okay. That's interesting in your perspective.
Oh, okay. You still think that's unethical?
Actually, I'm not so sure that it well, I mean, this kind of throws a lot of research into doubt, but I'm not sure that it's a great idea to use models as a proxy for humans in general, which again throws a lot of things into doubt.
Oh yeah, I understand that. Yeah.
I do want to vote, building off that point, and then building off the my previous question about generalization.
Mm-hmm.
So if you're warning policymakers not to generalize outside of the training data, really how different is this than just like a really heavyweight summarization tool? I mean, it feels like we're just kind of trying to summarize the training data and see like what kinds of questions can be answered within the scope of the training data. And then really, if we're really afraid about generalizing outside, then it really just feels like we're just doing summarization, which there's a lot of approaches to summarization, right?
Yeah, but still, this is more than summarization, as we see that for summarization, you can only, for example, you want to learn the people's opinions on COVID vaccine, but what if the COVID vaccine, the data of that does not exist in the corpus, but still there are some data on other topics such as abortion or like climate change. In that case, summarization would not work. But in our case, the model can still extrapolate the opinions of COVID vaccine from like climate change and other topics.
Yeah, I mean, I thought we just had this whole discussion about how like you put that in the ethics section that you're warning people against doing that, though, right?
But no, like I'm just against like to generalize totally across different domains, like from politics to like to weight loss. But within politics, we are not against that.
Okay.
Yeah, so you can generalize to a certain degree, but not too far. That's what I mean. Yeah.
I kind of feel like that needs to be studied more. I feel like that's a very empirical question, and we have to have numbers on what degree.
Yeah, exactly. Yeah, we're also like thinking about that questions right now.
All right, are there any other questions? Well, thank you so much, Zihao, for your talk. I really enjoyed it, and we're all gonna go have meatballs for a holiday lunch after this. So, see? Peter, you're welcome to stop the recording.